Okay, hi guys. I will take this opportunity to let you know that I'm going to be out a couple of days on a accreditation visit, which I'll tell you about when I get back. But I'm anticipating that you had trouble with number 5 because last year they asked about it. So it's usually a pretty good guess. And you have a product rule here and a chain rule here, so it's a tougher problem. So let me try to go through this problem right now for you, which was on your homework over the weekend, so that you can succeed on tonight's homework, ideally. So if we're taking the derivative of this and we're taking it with respect to x, like we're manipulating the x variable, we kind of are like basically doing this, taking the derivative of everything with respect to x. And it's kind of like everything has to get its derivative taken. So this thing right here is easy because the variables match and you just use your power rule. Okay? That's done. But now when you're taking the derivative of this right here, right, you pretty much want to know what is, oops, you pretty much want to know what is negative xy, right? What is that? Prime. If you take the derivative of that, this is prime, not a 1. And that's going to be the derivative of the first times the second as is, plus the derivative of the second. But what's the derivative of the second? Well, that's derivative of y with respect to x. So because the variables didn't match, we had to use derivative of y with respect to x. Derivative of the second times the first. So that whole deal. Okay, so I'm just going to kind of like simplify that. That's negative y, right, minus x dy dx. Basically just a simplification there. So that shouldn't be too bad. Now we have this one, which the derivative of y squared, we're still doing the regular derivative, so it's still going to be positive 2y to the first power, right? But the chain rule says that I got to take the derivative of this, and because this is an x, right, which in this case it was x, and so the derivative was just 1, and there was no chain rule really, it was hidden anyways, this derivative has to be taken. So because whenever you're manipulating that y, you need to write dy dx, and then the derivative of 4 is going to be 0. So now we're in pretty good shape, but here's where it gets tricky. We want to basically solve for dy dx, because that's what we've been doing, right? When we take y prime, that's equal to dy dx, and that's the slope of the tangent line, the rise over the run in some sense. So we need to solve for that. So let's move anything that's not attached to that dy dx. Let's subtract the 3x squared, and let's add the y. So I now have negative x dy dx. We'll go a little bit slower here. Sorry if the pen is making a nasty scratching noise. I don't have an external, I don't have a mic attached right now, so we're dealing with that issue. So here's negative 3x squared plus y, that's fine. And so that's basically that. We've moved those terms over. Now here's the thing. We want dy dx, so I'm going to take the dy dx out, like so. And I'm going to change the order just because of this. Makes it look a little bit nicer. Change the order here, might as well, right? And now we need to get dy dx alone, so we need to divide by this right here. This is the example that we didn't quite get to the other class on Friday, I believe it was. Now we have dy dx. This is literally the derivative. Now it's a mixed up, messy thing, but that is the derivative of y with respect to x. If you had points with x and y's, like numbers for x and y, that were on this curve here, or whatever that is, it's some sort of curve, I'm sure. If you plug those in, you'd get the actual slope at any of those points. So this is what we're looking for. dy dx is this. So there you go. You get your chain rule. You're understanding that you need to use the dy dx whenever you take the derivative of y. This stayed a plain y. Where was that? Here, because it was a product rule, right? Derivative of the first times the second as is. Derivative of the second times the first. So this is something to see. It's important. And then the factoring out of the dy dx is tricky, but not really that bad. So a lot of your answers in the worksheet are going to look something like that. Okay? So just keep working on it. You'll get there. I don't think there's too much more to it. I mean, let's consider at least a couple things that might be important to understand. Like, let's say we had like ln of y equals, I don't know, x cubed, just so we can have an idea of what this is talking about. If you were going to take the derivative, and I'm making this up, so this could be a little bit tricky, but the derivative with respect to x, let's just say derivative with respect to x. Okay. Well, the derivative of ln of y, well, that's going to be 1 over y, but there's a chain rule that says dy dx equals 3x squared, and that's fine as is. So dy dx, right, we have to multiply by y now, right? And dy dx, in this case, is 3x squared y. So that's another understanding, like another thing that you can understand, because this could happen with a cosine or sine, anything like that. You've got to, every time you actually are manipulating, taking derivative with a y with respect to x, you get this dy dx. Okay, and it's kind of complicated for now, but just try to get in that habit, and we'll talk more about what it means in the future. But that's going forward. Okay, I don't want to keep this too long, so I'll see you guys soon.